So hello viewers, I welcome you all on the behalf of DSC KIET to this session on scaling with serverless in association with DLT Labs. DSC KIET is a community of developers who learn, grow and code together. Visit us on our website dsckite.com for future updates. Before starting the session, I would like you to introduce you all with our speaker, Mr. Shomik Goswami, who is currently working as a software engineer at DLT Labs and is our prestigious alumni of 2019. He has a great experience with working with Node.js and microservices and is here to share that knowledge with us. Thank you, sir, for being here. Over to you, sir.
Thank you. Okay. Is my slide visible, Rohan? Hello. Okay. All right. Hi everyone. First of all, thanks to DSC KIET and DLT Labs for organizing this event in collaboration and inviting me to give this hands-on session on serverless and AWS Lambda. So today we are going to learn about the big guy in town, serverless in general, and then AWS Lambda with it. And along with that, how to use them to scale your web applications. We are going to do some kind of a crash course on these topics, and I'm making an assumption that you guys know about Node.js and have at least made some programs in that. Nevertheless, there are no other prerequisites for our talk today. So, a little about me. I'm Shomik, who's really interested in programming, and especially when it comes to server-side scripting or system design. At the same time, I'm a software engineer at DLT Labs, working on one of its core platforms. So yeah, that's pretty much about me. Moving on, what is this session all about? So first, we'll talk about serverless in general and why there is a need to use such a model. Then we are going to see one such serverless service provided by one of the most popular cloud service providers, Amazon Web Services. And then we are going to deep dive into it, and we'll be using Node.js as the language of choice. And then I'll wind up the session by giving you guys some more things to explore upon. So let's get started. It will be a long session, so brace yourselves for that. So first of all, what is serverless? You know your applications are composed of only functions at its core. So serverless or function as a service means we write and deploy individual functions rather than your entire applications. I'm repeating that again. We write and deploy individual functions that your entire applications in serverless or functions as a service. In here, each function has distinct needs and handles a distinct event, like a web request. This is the very reason why it is sometimes called a function as a service. The functions you write are only loaded in the memory when there's a request or an event for them to handle, and then they are unloaded from the memory after. Even they also share the same hardware and even possibly the same runtime with it. As a result, you only pay for the CPU and other resources consumed by your functions and not the entire server or the VM, which we used to do before. So serverless is being pretty extensively used these days, and it's constantly growing. So again, functions as a service is being able to deploy functions in the cloud and then run those functions based on some type of fee they have subscribed for. Now you would have got it. The difference between your functions as a service and your typical server is that your server is basically a long-lived server that's always running on some port and is listening for some HTTP requests. In serverless, it's not like that. First, they are not long-lived. As discussed previously, they only spin up when they are subscribed to an event and when that event happens. And after serving that event, they shut down automatically. So yeah, they are stateless. But on the cloud, everything comes with a charge. And most platforms charge you per usage for that. But AWS is one of the cheapest And that's what we are going to talk about in the upcoming slides. And now, what is this Lambda, AWS Lambda? That's basically the name of functions as a service offered by AWS, Amazon Web Services. There are other given by very big names in the industry, such as Google with Google Cloud Functions, Microsoft with Azure Functions, and even Alibaba with Alibaba Cloud. But as previously said, AWS is one of the cheapest and at the same time performs very well. And it's constantly improving day by day. So yeah, Lambda is basically AWS name for function as a service. Now, the one thing to point out for every beginner in serverless is the difference between serverless and the framework serverless. Now, when people say that they are using serverless architecture, they are not probably talking about the framework serverless offered by Serverless Incorporation. They are just talking about using it in Lambda or Google Cloud Functions or an Azure. Deep diving into serverless without going through this framework called serverless is just a mistake now. Now, this serverless framework is like a build system or an environment around all the major platforms that have function as a service. And then this framework gives us a common API to interact with all the major platforms, such as Google, Amazon, and even Alibaba. We are going to see that in a bit. That's all we are going to use in this session. Now, without this framework, for example, AWS is very difficult to handle for someone who doesn't have extensive experience with some type of cloud platform to deploy these functions. But with serverless, it's very easy. It's like using any other npm package now. So yeah, it's a framework built to ease off the work of working with serverless offerings of major cloud platform providers. Now let's get down to creating a hello world Lambda function. To get started with a deep dive into Lambda, and to create a Lambda function, we are going to use Node.js. So let's just take a tour of a couple of things. First, you need to install the serverless framework globally through your npm for Node.js. Let's do that. Uh, okay. So Rohan, is my PowerShell visible? Okay. Wait a sec. Is there option to do that? Yeah. Is this fine? Okay. So first you need to install the serverless framework globally through your npm for Node.js. Let's do that. I did for myself. You can do the same by just running this command npm I serverless -g. So make sure you install that globally so that you can use its CLI anywhere, anytime. I've installed it already. You can install for yourself by using the same command. So to check if it is installed correctly, you can invoke its help command by typing serverless -l. Okay, so you can see that it listed down for us a number of commands. We'll be going through some of them in this session. So now for our session, what I'm going to do is use the serverless framework we just installed using this command npmi serverless -g to set up a basic project for our Node.js to implement serverless by making a Lambda function. Now, if you are going to see a list of commands that serverless accepts, and one of them is create for creating a new serverless service. Says create new serverless service. Yeah. Now with that, you can pass a template with it. It's just like your boilerplate code. Let me go to. Let me show you all the templates we have in here. The official website for serverless framework. Okay, search for templates, and it will list down all the templates for all the major platforms. And we are going to, even there is one for Tencent, the makers of PUBG. They are, even have their cloud service for and yeah, we are going to use for AWS. The template basically signifies that what language do you want to start with, meaning what language and for what platform you want to write your serverless function in here. And there's tons of templates to use. We are going to use Node.js for the AWS platform, so we are going to use this template. So if you see this command down here, you can pass it what you can pass it a platform, then your language of choice, and then you can also give your serverless service a name. I'm going to talk about what the service name means when we'll go and deploy our Lambda function. For now, just think of it as your serverless project name. And now this command will create a function with that Lambda function. For now, just with that language for the specific. So in our case, we have to create one for the AWS platform using Node.js. So we are going to use this command right here. Serverless. Wait. Okay, so this will take some time in creating for creating a boilerplate code. So yeah, the message shows that it is successfully generated. So now if we go to AWS, to our Visual Studio Code, and open that folder. So now if I open this up, you get a boilerplate code of a serverless function here. In our case, it's AWS Lambda. So now if we get to this one file called handler.js, uh, handler is the term that Lambda and most functions in other platforms use to describe the actual function that's going to be deployed on your language of choice, platform of choice. In our case, it's AWS, so it's like an entry function. It's the actual Lambda that will get deployed on your platform of choice. Although a Lambda could call other functions, be it other Lambda functions or simple functions in your code. So basically, serverless generated a handler over here, and just by the looks of it, and if you have ever written any kind of API, you would know that serverless generated by default a handler for an API, because we are sending back a response with a status code in here. All Lambda functions necessarily are not required to be for an API. So yeah, that's how a Lambda function looks like. We'll talk about all the parameters in depth in a minute, but let's have a quick glance over everything for now. And then if you go to this serverless.yaml file, which is in itself a configuration file, because it's a YAML file after all. This is the configuration file for serverless itself. So as you can see, it's very well documented. There are so many options to play around with. Okay, just a sec. But the important things to remember is one, this service, which is just a namespace for a group of Lambda functions that you will be creating in your project, in your serverless project. So you can put make project and you can deploy them together or separate it. And then if we go down, and then for this provider, because we chose AWS as a platform of choice, and Node.js as a language of choice, it went ahead and initialized a config with these values. That's why we had used that template in the beginning for automating this. Sorry. Then we go down, we can find this functions property, which is where all the magic happens. So in here we have a function called hello. You can put anything here you want here. That name is just the name of your Lambda function that will show on your AWS platform, but it has nothing to do with your file name, and you'll be seeing that in a bit. It's simply the name you want this Lambda to be shown as on the platform that you'll deploy to. And after naming a Lambda function, we have to tell serverless where is the source code for this Lambda function that we have named hello. The way you do that is you add a handler property here, and then you give it a path to the file that has the Lambda function, and then and this path is relative to this serverless.yaml file where it resides. This dot hello is the name of the export from this handler file, if you remember. Yeah, this is here. So let's run this Lambda for now. And there are a couple of ways you can do that, and because we didn't set up an API, we can invoke this function locally. So one way of doing this is by using serverless invoke local. uh, Serverless invoke local, and yes, you have to pass in local, because if you don't do that, it will try invoking it in AWS itself. And as we have not deployed it to AWS, this project will break. So now we have to invoke it locally just to see that if everything is working fine. You have to pass it to give the name of the function that you actually want to invoke. In our case, it's hello, the name of our Lambda function. This will invoke the same method that was exported from the handler. Let's run it. Let's wait for its response. Yeah. So this is what it returned. The same what we returned from our handler function. So again, if we go to this handler.js file, so in the older versions of Node.js, prior to 8.10 runtime, there used to be three parameters here, namely event, context, and callback. But with the latest version of Node.js from 8.10, since 8.10, we can simply return the response now. We don't need it, because with the latest Node.js version, they introduce promises, async await to handle all such ambiguities, such as callback hells and everything. The Lambda programming model for Node.js 8.10 now supports defining a function handler uh, using the async await pattern for asynchronous programming. Previously, there used to be a callback method which you had to invoke at the very end with an error or response. But as programming evolved in Node.js, such methods created problems for us, such as callback help, and even with the introduction of promises. Nevertheless, there are still two parameters here. You can even use context here. Uh, and then, yeah. Nevertheless, there's two parameters here which get initialized with when invoking Lambda function, which we'll be going through in detail in a minute. So yeah, that's pretty much it. That's your Lambda function. The main concern arises when we deploy this Lambda function to AWS, and how to trigger this Lambda basically. So there are a couple of ways of doing that, and how these arguments look depends completely on how your Lambda function is activated, what triggers it basically. So let's create a serverless service from scratch by ourselves, not using the serverless create command. And in that process, let's explore more. Let me create a new folder. So let's create serverless.yaml file at first. So let's talk a little more about this serverless.yaml file. Let me give it a service name. Okay. Okay. Sure. Fine. Let's talk about this provider section. We can add a couple of more properties here, namely profile, in which you have to type in your AWS profile name. It's like sort of credentials. This is basically for AWS permissions. This will matter when we'll deploy a Lambda functions onto the cloud. Uh, it's not that big of a deal right now because they're just invoking everything locally, right? And we have a couple of more properties, like for example, region. And this so region you want to deploy to, and what stage. And these are again related to our deployment on AWS. We'll talk about it in detail when we'll deploy it. And now we have one more called plugins, which is exactly what it sounds like. We are telling AWS what plugins we want to use in our Lambda functions. So let's modify this project for now. We don't have to use plugins. Any kind of plugin. And a Lambda function. Okay. So I'm making a hello world handler file with the exported function named as hello world. Let me create a new folder. Uh, we have to change a config in the YAML file as well. Yeah, if you remember, I told you that we have to specify the source file path in accordance with the serverless.yaml file where it resides. So, dot the name and exported. Now this handler function, let me write a boilerplate code for explaining you guys. Now, so now this handler function has two formal parameters, which are your event and context. You can call these whatever you signifies meta information about the execution context of your Lambda. So when invoked locally, there won't be anything inside of it unless you pass something in it. There will be some context if you run this either on AWS or with serverless offline, which we'll see in a bit. There can be tons of context about the execution of that function that will help you do things in future. And then we basically return our response in here. Or if you want, we can even return an error. This is done at the very end after doing everything inside. For the sake of simplicity and for understanding it better, for this event parameter, let's define the payload to be sent to this Lambda function as a separate JSON file, so that when invoking it, we can pass it to the Lambda function. Let me create. In here, you can pass. So now, so yeah, I guess there's a separate flag for that. Let me check. You can check that by using the help command. Sorry, we have to check the help for serverless invoke. It takes time. So yeah, there it is called path. It says that you can pass a path to JSON or YAML file, and it will take that JSON file and it will pass it as an input, that is payload, to the Lambda function when invoking it. Obviously, let's do that. Invoke. Okay. Then we have to write the name of our Lambda function. Did I name it hello world? Yeah, hello world, and then the path to that event.json file, the payload actually. Let's see. Wait a sec. I didn't save this file. ebt dot. Okay, let's see. JSON. Oh, sorry. Sorry. Uh, the name of the profile is incorrect. I have to comment these out because I have exported those on my system. I'll be talking about that in a bit. Yeah, that's the event that is in the file. Now the same Lambda may be used in another event, so it will have everything different. Different event, different context, and most of the time running serverless invoke local to test out our Lambda functions locally doesn't work, because these Lambda functions are responding to whole lot of different events when you deploy them to the cloud. So the only way to test Lambda functions locally before routing production traffic to it is to get a copy of the event from AWS, paste it in your that. But if your Lambda function relies on other services of AWS or any other cloud service provider, then it's really hard to test it locally. The only option left is to deploy it, run it, and debug it in the cloud. Now, there are two different ways of executing a Lambda function. There's synchronous and there's asynchronous. So in the synchronous mode, you call a Lambda and you are waiting for the response. For example, an API event where one client requests something, it waits for the response to come. Asynchronous mode, you fire an event and you forget about it. It's not going to respond back to you. For example, updating something in S3 or send an email in the background or something like that. Now this can be controlled by calling the Lambda function yourself using AWS SDK. Therein you can specify explicitly that I want to call this Lambda function synchronously or asynchronously. And even you can specify in here async. That's the new Lambda programming model. We call our Lambda function. Now I'm removing this because everything is synchronous now. Now moving on, let's talk about a very important thing, AWS event types. Which is the most important thing in AWS Lambda. And for that I have to go to my AWS profile. uh, Go to my AWS profile. Click on AWS management console. And for that, yeah, so you can make one for yourself. It's very easy. You even get a free trial for 1 year for so many services. In any case, you have to make one to deploy your Lambda to the cloud. So this is the AWS console, which they call as AWS management console. We need to search for Lambdas. Let me search for that. And this is where we'll be doing everything. So what we did before was we created a Lambda function on our machine using the serverless framework. But now we'll see how Lambda functions were made when there was no serverless framework. So this is where someone has to make one by clicking this button called create function. For the time being, I'm going to use this Lambda function I already created. This looks way better than it was before. AWS has really improved the experience now. But what I want to show you were these Lambda events. Sorry. So yeah, uh, at, so I wanted to show you these Lambda events to test your Lambda function with, uh, and these are all the events that your Lambda can subscribe to. There are a ton of events here. You can find Alexa events, you can find Lex events. uh, one such is this Amazon API gateway AWS proxy, which is used a lot and which we'll be using today as well. This is basically letting Lambdas respond to APIs in AWS. Another one is this SES, I believe. Yeah, a simple email service with AWS, and we can subscribe our Lambda to all the events coming through it, and we can do a whole lot of crazy things with that. Now, when you click any one of them, let me click the Amazon API Gateway one. You would get a sample JSON object where you can copy this object, paste it in your event.json file, and test it with that to prepare your Lambda functions to handle such event payloads. That is why I chose that kind of workflow of separating the payload as event.json file that has to be sent to your Lambda function as event. Now to test it, you can simply copy this JSON object, paste it in your event.json file, and make Lambda functions respond to such type of events. Basically, prepare your Lambda functions such as to respond to these events. So this is how you would test it on AWS itself. Let me test with this basic event. Okay, test it. This is what it returned. So all this we can do pretty easily with the serverless framework, and you can do much more than that. But how does serverless do that? Serverless uses something called cloud formation for AWS. I search for cloud formation AWS. It states that it's the infrastructure as code for AWS. So cloud formation is basically an API service that ties all these AWS services together, which you can use it from the CLI. Serverless uses that. You basically create a configuration file, which is called the cloud formation template file, and you send it to AWS. And then AWS creates all the stuffs for you, which you have mentioned in your template file. It simply automates creating resources on the AWS. AWS cloud formation orchestrates the provisioning of your desired resources. But even this template file is very hard to use and make it. That's why we use this layer of serverless, which is an abstraction of AWS cloud formation, which is in itself an abstraction over all the AWS services. We are using so many layers of abstraction now without knowing. That's how it has become easy to create Lambda functions now. Um, so basically, all the AWS services which are available in AWS Cloud Formation are also available in serverless to use for a Lambda function. What that means is we can configure for those AWS services in a serverless.yaml file in a Lambda project. Now that we have covered the basics on how the Lambda works, the event types, and almost everything, let's get down to creating APIs. That's the very basic real world application we can use Lambdas for. So there's this thing called API Gateway in AWS. You, I just showed you the event for that AWS API Gateway, AWS proxy, and it's simply a gateway for your API. You can think of it like a proxy to your API. That's why the event name also had AWS proxy in it. So this will be in front of your Lambda function. It will be responsible for routing all our HTTP events to our Lambdas. Now you can create an API directly from here, from the AWS console, but we don't have to do that now. We have serverless framework for that. We can handle the same from the serverless.yaml file. And if you remember, the event we are going to subscribe to is AWS API gateway. Let me show you again. Amazon API gateway, AWS proxy. Uh, but please note that the payload that AWS API gateway sends is pretty much one sec. Yeah, yeah. So please note that the payload that AWS API sends is first formatted from the API gateway and is then fed into a Lambda function as event payload. Now there's two different API gateway events. One is proxy, and the other one is forwarded request. We'll always use proxy as our API gateway because when we do that, it gives our lambdas the power to actually control how our response will look like. Now, if we use the forwarding one, we have to go to API gateway and explicitly define what the response object will look like. Even the serverless framework by default uses the proxy implementation of the AWS API gateway, and that is the way to go. So now let's hop into Visual Studio Code and start modifying our existing Lambda function to handle API events using serverless. Let us go to this handler file. Sure. So yeah, so let me first configure the handler name that I just mentioned in here. Is the same name that you have to use that you have exported from your handler file, and you have to name our Lambda function something. I'm renaming it to API. And I'm subscribing to all these. I will be talking about in a bit. Let me first write. Now instead of invoking your Lambda function locally using serverless, what we did before, we are going to make our Lambda function listen to HTTP events. How we are going to do that locally? So if we go to this serverless.yaml file, we had a property called I mentioned you before that we had a property called plugins, where we could list down all the plugins we could use for a serverless project. One such plugin is called serverless offline. Uh, Let me show you. Yeah, so we are going to use a plugin called serverless offline. In that, what it does is it starts a serverless offline for us and invoke a Lambda function according to the HTTP event. So as we saw earlier in our AWS console, API gateway is something as a long-lived server that sits between your client and your Lambda function. What serverless offline does is it emulates the same on your local as an API gateway. Now it is the role of this API gateway, that is serverless offline, to pass the event payload to our Lambda function in here, what we did before manually through serverless invoke local -p path, giving the path to the event.json file. So let's send a response to our Lambda function. This is the response we are sending to our Lambda function, and we are using the proxy method. So API gateway calls our Lambda function with the event payload, and then our Lambda function sends a response by simply returning it to API gateway, and then our API gateway sends the response back to the client. So API gateway in a way acts as a medium between a client and a Lambda function. So in order to send a response back to the client in a predictable way, the Lambda function has to send a response to API gateway in a predictable way. So API gateway gives us a format in which we have to respond to them. And that format is very usual if you come from a web development background, which I just coded it in here with a status code, headers, which the response headers, and a body. So now let's execute this locally. So to use serverless offline, we have to install it on our machine. So first do that through npm install. Again, install the same globally. Let's wait for that. We have successfully set up a Lambda function to respond to HTTP based events. And we have subscribed a Lambda function to an API as well, so that it can listen for it. In our case, it has to be an HTTP based event. So for that, we have to add a property called events just after registering a Lambda function in the serverless.yaml file. This allows you to register those events that your Lambda function can subscribe to. So what I so what I did is use a shorthand notation for specifying the HTTP method and the route. So now what this says is I have a Lambda function named API whose handler is this source, and it's going to subscribe to an event. In our case, it's the HTTP event. And for that event to get triggered, we can do a GET request to this API. But at the same time, you guys can configure these options in a more advanced way. Like, let me show you. Okay. Using the long version of that, you can specify the path, specify the method, and even cross-origin resource sharing. You can even do that. So now when someone does a request to wherever my API gateway is hosted, slash API gateway will simply trigger an HTTP based event, and as a result, the Lambda function as well, uh, and our API gateway will send the formatted request payload as the event payload to the Lambda function. And then the API gateway is going to wait for a response or an error from the Lambda function. And as soon as it gets it, it will respond back to the client. Now we have two ways to test this locally. One way is to just copy the event payload from the AWS and simply paste that into our event.json file. But it's not that realistic. To test the whole flow, you have to run it through the API gateway itself. And that's where the serverless offline plugin comes in. Um, so you can just run serverless offline. Yeah, it got installed. You can just run serverless offline. Let's see. Just a sec. Just a sec. We have tested the plugins here, and I normally don't use this plugin. For this session, I just Googled that up yesterday. I normally deploy my Lambda functions onto the cloud. Please just let me see. Is this the thing? I don't know for what reason it's not running right now. Let me check the docs for that. Service. So this plugin emulates. Let me first. Let install that as a dev dependency. Oops. Wait for it to finish. So basically what it does is that it emulates itself as the API gateway. It will trigger an HTTP based event and will pass an event payload to a Lambda function, and your Lambda function will work with that and will return a response to our serverless offline, and the serverless offline will in turn return a response to the client, which is us locally. So let that finish. So in the meantime, I would like to explain a little more about Lambda and what is its architecture. So when a Lambda function is invoked, AWS Lambda launches an execution context. This execution context is a temporary runtime environment that initializes any external dependencies of your Lambda function code. Basically, Amazon Web Services, AWS, spins up a container, and that container gets recycled. And it is in this very container that your Lambda gets executed, and uh, all your external dependencies are initialized. So, for example, you haven't executed your Lambda function up till now, and suddenly you do it. AWS creates a container, and that spins up your Lambda function inside of that. So that's a cold start here. There, it will take some time to do all of its things for the very first time. So if you hit your Lambda function again within the duration before AWS recycles that container, then you're good to go. It is fast. It responds back to you very fast. It will be fast because it's in memory. There's no need to load up everything again. In a way, it will help you decide your architecture calling Lambda functions, because you would know that your Lambda function takes some time initially when you hit it for the very first time. And yes, if you have a question that by when a container gets recycled again, no one knows about the exact interval. So yeah, one design practice is that you can always hit your Lambda function in some intervals, so that it is always in the hot state. It doesn't have to be in the cold state then. But then, yes, you have to guess the time in which you have to hit your Lambda function again and again. Now, don't know what's messing up in here. Uh, um, let's see that we deployed it to the cloud. Uh, uh, but for the meantime, you can you should know that you can use serverless offline. I don't know why it's not getting installed, and maybe there's some kind of connectivity issues in here. So yeah, now let's move on. Now, to pass in parameters for your routes, you could add a placeholder in your route in the serverless.yaml file. Pass in here that you need an ID with your route as a URL parameter. You have to specify one more attribute called request for that. No, in here, request for that parameters. So we haven't. So what it does is that it tells your API gateway that go through the ID uh, URL parameter, and make it available in the event payload that is to be sent to your Lambda function. We haven't talked about the context parameter in our Lambda functions. Let's look into that for a bit. So it really depends upon what you are doing and what platform you are using to execute your Lambda functions. For our case, that is serverless offline. It is not that helpful because everything's local and we won't be operating on anything which is local in the real world, but we'll still see its output and the way it's formatted, because once we deploy it in the cloud, we'll be using that for sure for doing a couple of things. It's upon you and your specific use case. So I want to list down some of the context parameters, uh, what is listed down when your Lambda function is invoked. One such is your function name. You can check the docs for that as well. Uh, so your context is actually giving more of the platform information rather than the event itself, because your event is doing that. That is the name. So this function name is the name of the Lambda function you are actually executing. There is something called versioning as well, I believe. Yeah, there is. Uh, you can actually version your Lambda functions as well. You get the ARN as well. All these I remember because I've been using Lambdas so much these days. So if you don't know what ARN is, it stands for Amazon Resource Name. It's basically a unique identifier for every resource in AWS, be it anything in S3 or even your Lambda functions. Then you even have your AWS request ID, uh, which is basically an ID given to every request from a client by your AWS API gateway. And then you even have a log group name and the log. So basically, when you deploy to AWS, serverless creates a log group for you so that you can have a look at the logs. So this is the group name uh, and the stream name of those logs. So what it means is that when you log inside your Lambda functions, AWS, those logs get written to a file. So this is the group name and the stream name of that file. This is the purpose of this group name, and you can even stream them in your group name, and you can even stream them in your terminal from AWS through this log stream name. And then we have this one property called uh, identity, which is when you are doing a custom authorizer. Like for example, if you have a Lambda function in front of this Lambda function, then you can authorize from your front-end Lambda function to this Lambda function. AWS has this one cognito, I believe. Let me that. Yeah, which is their version of OAuth, and it does things like social auth, password auth, JWTs. If you use that with your Lambda function, Cognito will add up things in here, that is identity, and then context as well, which is just the context sent from the client, and this is basically what the context object looks like. This is pretty much it. Now we are probably in the final stage of a session where we are going to deploy a Lambda function to AWS. So there are a couple of ways you can use to deploy your Lambda functions using the serverless framework. So if you go to this, so if you go and type this serverless dot command, let it load first. Yeah. There are a couple of things to note. So one way to do that is by using this deploy command, which says that it deploys a serverless service. So what is this serverless service? Remember, if you go back to our serverless.yaml file, and uh, yeah, we did mention a service name here. This is the serverless service. You can name it anything you want. Basically, this service consists of pretty much all the functions that you are going to list down here in this YAML file. You can also have multiple services in a single repository. You simply put them in